Hey guys! So we're going to go ahead and jump into our tricky topics for chapter 5. In this video, we're going to talk about lethal allele and then other with therapy epistasis, sex influence, sex limited, and genetic maternal effect. So just a pre-warning about chapter 5, this is usually a pretty hard chapter for a lot of students, just because the content is something that you've never ever heard before. A lot of you guys have probably heard some stuff from chapter 2, 3, and 4 before, maybe not in as much depth, but you've heard of it. And this is completely new. So a lot of times it can be a little difficult to understand when you first hear it. So I would just recommend spending quite a bit of time just re-going over it until it is more familiar to you and it makes a little more sense. But the first time you hear it, it will be a lot and it will be confusing, but don't be discouraged. So let's start with lethal alleles. So as you can see by the name, you can kind of guess what this is about. This is whenever some genotype is going to be lethal, as in the offspring isn't able to survive. So the way that you can think about this is like conditional probability, where one possibility can never happen. So we know in conditional probability, that was whenever you would have like cystic fibrosis is an autosomal recessive disease. Two heterozygote parents are crossed and they have a child without cystic fibrosis. What's the chance the child is a carrier? So in that case, because I told you child without cystic fibrosis, you had to go to your little Punnett square, cross out that little AA in the corner, and then now your options are out of 3. It's the same idea with lethal alleles. The difference here is instead of it saying like without cystic fibrosis or something like that, it just telling you that the offspring exists is enough, because if they're alive, that means they're not dead. So it's not as clearly stated in the problems like it is with conditional probability, where it has to tell you without cystic fibrosis. In this case, it's just going to tell you like an offspring is born, what's their chances? And if they're born, that means they're not dead. So you have to be a little intuitive here and think about that fact. So just like we crossed off the little a with cystic fibrosis, remember to cross off any genotypes that result in death. And again, we're going to change our little squares to be out of a different number. Changing the probability so that they add up to be one whole, just like with conditional probability. And in the problem stem, it's going to tell you what genotype is lethal. It's usually one of the homozygous ones, so either homozygous dominant is lethal or homozygous recessive is lethal. But you'll be told in the problem stem, you're never just going to be expected to know, oh, this is a lethal allele problem, and it doesn't tell you anything. So you should always be able to identify them. So just make sure after you identify its lethal allele that you go to your probabilities and make sure that they all add up to 1. Okay, let's go ahead and try a problem together. So in cockroaches, being homozygous dominant for color is lethal. So that means that those offspring won't survive. And a note on being lethal, this is going to happen in like the first couple weeks that they're in the womb. So the sperm and the egg, if they're both like big A's, they'll still be able to combine. And then there's going to be something about that big A that causes developmental processes to not happen. And that's when a miscarriage would result or something like that. Okay, so it's lethal. Brown color is dominant to green color. Okay, 2 brown cockroaches are crossed. What are the probabilities of their offspring? So let's notice here, homozygous dominant is lethal. So I'm just going to make a note right here. AA equals not possible. We're never going to have a kid with big A. Okay, let's look at our cross. We have 2 brown cockroaches are crossed. And we know that brown is dominant to green. So usually whenever we're given the dominant phenotype, we know that there's 2 possibilities. Brown could usually come from big A, or big A little a. So ignore the fact this is lethal for a second. If you're just told brown and brown is dominant, you're like, okay, there's 2 genotypes. But in this case, if they're mating together, we know they're alive. So again, we're being a little intuitive here and realizing, okay, they can't be big A, otherwise they just wouldn't exist. So in this case, any dominant phenotype, instead of having 2 options, only has 1. They have to be big A, little a. All right, so let's cross those 2 cockroaches. And I'm going to do a Punnett square just so that we can show the crossing out the square. It'll make it a little bit easier to understand. But in an actual exam, if you guys can get to the point where you can just kind of see it without having to draw out the square, that will be really helpful for you. All right, so I have my little square. Okay, so looking at this square, it could be really tempting to say 1/4, big A, 2/4, big A, 1/4, little a, and move on. But we were told that one of these is lethal, and that means that they're never going to have offspring with these genes. So this one right here is not possible. The probability of this one is actually 0. It's not 1/4, it's 0. So I'm also going to cross off this square right here. So you'll notice now the probabilities that we have left, if we didn't change them, it's 2/4 and 1/4. That only adds up to be 3/4. But if those are our only probabilities, and that's our whole thing, it should add up to be 1 whole. That means we have to adjust our numbers. So if you look at this little Punnett square down here, you'll notice now there's only 3 options. 2 of those 3 options are the heterozygote, and 1 of those 3 options is the homozygous recessive. So I'm going to change this to 2 out of 3, big A, little a, and 1 out of 3, little a. So you could say that by genotype, or you could say there's a 2/3 chance that they're brown and a 1/3 chance that they're green. And that would be your final answer here. All right, I hope that made sense. So the next video we'll be going through epistasis.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.